In this video, I want to have a look at how we can find the sum of a given number of terms in an arithmetic series. So there's two formulas for adding up n terms of an arithmetic sequence, and they're both on your formula sheet. Really, they're the same formula, just with a couple of different changes to it, just rewritten in a different way, but we'll have a look at both of them. So to figure out what this formula is, we're going to have a look at the sequence 2, 5, 8, 11, 14, 17, and we're going to add up those first 6 terms. So we'd write that as S6, so the sum of the first 6 terms would be 2 plus 5 plus 8 plus 11 plus 14 plus 17. Now what I'm going to do, I'm going to rewrite that, so I'm going to write it as S6, and I'm just going to write it backwards. So I'm going to write it as 17 plus 14 plus 11 plus 8 plus 5 plus 2. Now if I add those two things together, I'm going to have S6 plus S6, so I'm going to have 2 S6, so I'm going to have double because I'm going to add them together. Now if I add my 2 to my 17, that would give me 19. If I add my 5 and my 14, that would give me 19 as well. My 8 and my 11 would give me 19. The 11 and 8 would give me 19, the 14 and 5 would give me 19 as well, and the 17 and 2 would give me 19 too. Now that's going to give us 2 times S6. So to get S6, I'd have to do a half times all of this, which I'm just going to shorten down to 6 times 19. Now we could actually calculate that to get a final answer, but what we're trying to do here is derive the formula and see the pattern that's happening here. So I'm actually going to rewrite this a half times 6 times 2 plus 17 rather than that 19. So what we've got here is this 6 is n, that's the number of terms. The 2 was our first term and the 17 was our last term, which we're going to call L. So the last term out of the ones that we wanted to add up. Obviously this sequence goes on forever. So this is a sort of process that we can use. We can write the sum of the first n terms will be a half times the number of terms times the first term plus the last term. So that's always going to hold true. So the way it's written on your formula sheet is Sn equals n over 2 instead of a half times n, a plus l, where a is the first term, l is the last term, and that's going to be Tn. So it's the nth term of that sequence. Now that's all fine if we know what that last term is, but sometimes we won't be given what that last term is. We'll be told the number of terms that we want to add up and the first term. So what we can do instead, because that L is just the nth term, and we know that in an arithmetic sequence the nth term is a plus n minus 1 d, we can replace that L with this whole thing. So we'd end up with Sn equals n over 2, a plus a plus n minus 1 d. So that's the a that was already here, and then replacing the L with that whole thing there. Now I'm just going to simplify that to n over 2 outside of 2a plus n minus 1 d. So this formula is also on your formula sheet. They both are. It just depends what you're given. So if you're told what the last term is, you can use this one. If you're told the number of terms in the first term, you can use this one instead. Either way, you'll get the same answer. All right, so our first example asks us to evaluate this sum here. So we're given the first term and the last term, so that means we want to use the form of the equation that's Sn equals n over 2a plus l. So our a is 9 and our l is 224, but what we don't know at the moment is what n is. We don't know which term of the sequence that is. So we're going to figure that out. Because we know it's an arithmetic sequence, we know that it has to satisfy a plus n minus 1 d. So we're going to put 224 in here. We know that a is 9, and we know that d, well, from 9 to 14 we're adding 5, from 14 to 19 we're adding 5 as well, just to double check. So our d is 5, so we're going to have 5 n minus 1. So we can expand that out. We'd have 224 equals 9 plus 5n minus 5, which would give us 224, not 222. 224 equals 5n plus 4. We can minus 4 from both sides, so 220 is equal to 5n, which means that n would be equal to 44. So now that we know that as well, we can put it all in here. So we'd have the sum of the first 44 terms of the sequence, be 44 over 2 outside of 9 plus 224, which would end up giving me 5,126. Our second example asks us to find the sum of the first 25 terms in the series minus 2, 5, 12, and so on. So in this one, we don't know what the 25th term is going to be. So we're going to use the form of our equation that says Sn equals n over 2 outside of 2a plus n minus 1d. So we do need to figure out a few things. We know that a is minus 2 because that's our first term. And we know that our common difference from minus 2 to 5 is 7. And just double check, from 5 to 12 is 7 as well. So then we can substitute in. We also know that n is going to be 25. So we're going to have the sum of the first 25 terms is going to be 25 over 2 outside of 2 times minus 2 plus 24, because it was 25 minus 1, times 7, which will give me 2,050 as the sum of the first 25 terms. So that's having a look at how we can find the sums of n terms in an arithmetic series.